Hi everybody. In this lecture I'm going to show you the way that we rotate a coordinate system to have it our x, y, and z axis point any direction that we want. So this is going to be our x, this is our y, and our z. So these are the original coordinates. So this is good if you have some object that's oriented to space in a certain way and you want to rotate it some other way. And the way we do this is what was worked out by Euler, and we call it the Euler Angles. So you need 3 steps to rotate your object or your coordinate system to any desired direction. The first step then that we do is we rotate around this original z-axis. So what will happen is x will become x prime and it'll move over. We'll call this angle phi, and y becomes y prime, and it moves by phi. So to do that mathematically, we take our original x, y, and z, and then we were performing a operation on them, we're rotating them. Your new x, so this is going to be, we'll call it z prime, or no, I'm going to start with x prime, y prime, and z prime equals, it's x. So your new x will become cosine of phi x times sine phi y, and z doesn't change. Z doesn't play a role in your new x, just like in y it doesn't either. Y then will be negative sine phi cosine phi. Just to see that, I've drawn here your old x and y. Here's your x prime. So if you draw a line from the head of it straight over, so this is at 90 degrees, this side is cosine of phi, and then you would draw a line straight over, so it's 90 degrees to y. And so if you take 90 minus, so that would be cosine of 90 minus phi this side times y, and that'll be equal to sine of phi times y. So that's what we're doing here to get this. For z, it's not changing, so 0, 0, 1. So that's your first rotation. So we'll call that RZ, this matrix. Okay. So now we have our new coordinate system, x prime, y prime, and z prime. So the next rotation is going to be around the new x axis. So what's going to happen is your y is going to come up this way, and let's call that angle theta, and the z goes over this way by theta. So this is going to be now your y double prime, z double prime, and your x stays the same. So to do that rotation, now you're acting on x prime, y prime, z prime. And you're going to end up with x double prime, y double prime, z double prime. And that's going to be, so x isn't changing, y changes, and it's going to be, you can check this, but it's going to be cosine theta sine theta for y, and for z is going to be 0, negative sine theta. You can see in the y direction it moves that way, so it's negative y prime, and then a cosine theta. So let's call this Rx prime, because we rotate it around the x prime axis. So now we have our coordinate system like this. And so the last rotation is now rotate again around the z double prime. So x is going to go this way, y is going to go this way, so this will be y triple, or x triple, and z stays the same. And let's call this angle that it rotates through psi. So now we have x, y, z. The new coordinates, the final coordinates, are going to be in terms of x double, y double, and z double slash there. So for x, it's going to change very much like before. Now it's going to be cosine psi sine psi 0. And for y, it's going to be just like before with theta, but now with psi, negative sine psi cosine of psi 0 and 0, 0, 1. So this was r z double. So now, in general, to get your rotation, you would rotate. So these are the Euler angles. So first you rotate phi, and then you rotate, we call it theta, and then you rotate psi. So we start over here, x, y, z, our original coordinate system, and then cosine phi, sine phi, 0, negative sine phi, cosine phi, 0, 0, 0, 1. So that acts on that first. And then the next one was by theta. We had 1, 0, 0. This was rotating around the x prime. This was RZ. And then, so this last, this one is 0 cosine theta, sine theta, and 0 negative sine theta, cosine theta. And then the last step is this. And then that's just, it's cosine psi, sine psi, 0, negative sine psi, cosine psi, 0, and 0, 0, 1. So that's how you perform a rotation of a coordinate system. Using these Euler angles. We call that one RZ. Okay, so your author caused the transformation RZ, RX prime, RZ double prime, he calls that lambda. Okay. So let's say you only wanted to make the transformation around the x-axis, and you would only use this matrix. Now, whatever you end up with for a rotation here, let me tell you how you do it for like a moment of inertia. So this is acting on your coordinate system, your 3-component coordinate system. Okay. What if you have Let's see here. Let me get another piece of paper. What if you have a moment of inertia tensor? I11, I12, I13, I22, I23, and I31. So how do you do a transformation for this? So turns out these have to obey this. So you would say I prime, your new one, would be your rotation acting on I, and then over here you take the inverse of the rotation. So the inverse, by the way, if I have lambda 1, 1, lambda 1, 2, lambda 1, 3, lambda 2, 1, lambda 2, 2, lambda 2, 3, lambda 3, 1, lambda 3, 2, lambda 3, 3. To get the inverse of these, you take this row and you make it the column. So lambda inverse would be lambda 1, 1, lambda 1, 2, lambda 1, 3. The next column, 2, 1, 2, 2, lambda 3, 1. Oh, 2, 3, I'm sorry. And then lambda 3, 1. That row becomes this column. Lambda 3, 2, lambda 3, 3. So let's do at least set one up from your textbook. So problem I see 1117 gives you a moment of inertia of A, negative C, 0, negative C, B, 0, 0, 0, A plus B. And it wants you to do a coordinate transformation about the z-axis. So you're just going to have this original coordinate system. And you're going to just make a rotation around the z-axis by theta. So that was our very first coordinate transfer. So what do you do? If you remember, this was sine theta, cosine theta, 0, negative cosine theta, sine theta, 0, 0, 0, 1. I believe it was. No, I completely botched that up. It was cosine theta, sine theta, 0, negative sine theta, cosine theta, 0, 0, 0, 1. So then over on this side, I didn't make this big enough, but this row is going to be this first column, cosine theta, sine theta, 0, negative sine theta, cosine theta, yeah, 0, and then 0, 0, 1. So you would multiply these two together and then multiply that one by the result. I'm not going to go through that, but that's how you do it. And that's actually, the actual problem is 1118. And that's how you would go about doing it. Anyway, there's the Euler matrices. And then how you if you're going to make a transformation, how you transfer the moment of inertia.